In section 12 of chapter 2, which is the last section of the chapter, we're going to be graphing rational functions again, but this time we're going to be dealing with multiple transformations all at once and taking special note to accurately describe the transformations. I only have two problems with which I'm going to work with. The first one is y is equal to 2 times 1 over the quantity of x plus 4 quantity minus 3. Now notice when I said that verbally, I did say the quantity of, which means technically there are parentheses around the x plus 4, although most mathematicians do not write them. All right, so let's first talk about the description. The description is, since I have an x plus 4, there's addition of 4 next to the x, that means I'm going to have to move left 4. And I have a subtraction of 3 at the very end, and we learned that that shifts it up and down. That shifts it vertically, and that means we're going to go down 3. Because we do the opposite of what is next to the x, we do exactly what is on the outside, exactly as it's written. So a plus 4 next to the x dictates we're going to actually move left 4, and a minus 3 tells us we're going to move down. So here, a plus means left, a minus means right, but out here, a minus means down and a plus means up. Lastly, we are multiplying the entire thing by 2. We learned that that is stretching the function vertically. By 2. Now I do want to note, very specially, you do have to use all of these words. You have to say stretched or compressed if it's compressed. You must say vertically, and you have to tell me by how much. You cannot just say stretched by 2. Because stretching by 2 does not dictate what direction you are doing. Because you can take a picture, an image, and you can stretch it vertically, horizontally, diagonally. You can stretch it in any direction. This stretching tells me what we're doing, vertically tells me the direction, and the 2 tells me by how much. You must say the word vertically. Otherwise, that would be the equivalent of, instead of saying left 4, me saying over 4. Over does not dictate what direction I am going. So we need to say specifically what direction, specifically what direction, specifically what direction. I just like to make sure that I focus on that. All right, now that I've got my description out of the way, now I can graph it. Now again, these rational functions have a vertical and horizontal asymptote. That occurs at the center. So just like with exponential functions, rational functions center is actually not a coordinate that we are going to be graphing as a dot, but it's still important to notice, so we're going to mark it with an X. So I'm going to go left 4, 1, 2, 3, 4, down 1, 2, 3, and mark this location with an X. That X is the center of this rational function. It is the location where the horizontal asymptote travels through, and it is a location where the vertical asymptote travels. Now, normally, if there's no stretching or compressing going on, I would just go right one up one, draw a dot here, left one down one, draw a dot here, and then kind of just trace the shape of the graph. But because there's a stretching and compression, there is not going to be a dot at 1, 1 and -1, -1. These two dots are going to be in different locations. When we have the stretch by 2, this number is actually, when it's a stretch, going to give away what we're going to do. We're going to go from our center right, whatever the stretch amount is, so right 2 and up 1. There's our dot. But of course, we also learned when we were graphing the mother function, the parent function 1 over x, that every coordinate for rational functions exists both as an a comma b, but also a b comma a. So since this is 2, right 2, up 1, there must also exist a coordinate that is up 2 and right 1. There must also exist a coordinate here. Now that I got my two coordinates there, I can graph this part of it. Make sure I go through my two dots. Make sure I do not cross my asymptote. Then it's also true on the left side. So instead of left 1, down 1, I'm going to go left 2 and down 1. That's my first dot. And then there's also going to be its corresponding value down to left 1. So those are the two coordinates. And now I can graph on the bottom left portion. And this is the graph of the red function. For the blue function, okay, let's start with the description. It is y equals 1 over 2 times 1 over the quantity of x minus 5 quantity plus 6. Since I have a minus 5 next to the x, that dictates that we're going to be moving right 5. And since I have a plus 6 on the outside of the function, that dictates we are going to be moving up 6. The 1/2, for funsies, we're going to make it negative. It is going to be compression, because it is a number smaller than 1, and we're going to compress it vertically, and we're going to do that by 1/2. And I wanted to make it negative because we haven't dealt with one that has been flipped yet. Alright, so let's go right 5 and up 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, which is right here. My horizontal asymptote is going to go through that center. And my vertical asymptote is going to go through that center. Now, normally we would go right 1, up 1. However, for this one, it's going to be a little bit different because we are flipping it, so we're going to be graphing in the bottom right portion instead, and we're compressing it by 1/2. What that tells us is actually if we go right 1, we will be going down 1/2. So there's our coordinate, right 1, down 1/2. But it has a partner, which is down 1, right 1/2. So these two dots are really, really close, but they're technically a little bit off. There's our two dots to graph this rational function. What you will find is as you start throwing in smaller and smaller fractions for your compression factor, it's going to become much, much, much more box-shaped. And of course, we can also go on the left side, but on the left side, instead of being in the bottom left, now it's going to be in the top left. So from our center, we are going to go left 1 and up 1/2. That's going to be our first coordinate. And then its partner coordinate is going to be up 1 and left 1/2. There's our two dots. We now draw our line. Make sure you go through those two coordinates and you get close to the asymptote, but you technically do not cross it. And this is the graph of the blue function, y equals -1/2 times 1 over the quantity x minus 5 quantity plus 6. The last thing I do want to note is some special variations that you could use to write either of these equations. Namely, the portion right here. If I wanted to, I could have also written this as follows. 2 over x plus 4. That minus 3 still at the end as well. Because whenever you're multiplying by 2, that is a 2 over 1. You could multiply top times top and top times bottom. Also, for the blue equation, something similar can also happen, but this is going to be a little different. -1 times 1 is going to be -1 on top. And on the bottom, you could either write it as 2 times the quantity of x minus 5, all plus 6, or you could actually multiply out that 2 on the bottom and go -1 over 2x minus 10 plus 6. Now, while this formatting might give you a little bit of an indication of how far you're going to move left and right, whenever you multiply it all the way through in the denominator, notice this -10 does not tell us anything anymore. This is called factored form. We're going to get into that more detail as the year progresses, and you will be able to find out more and more information as long as it's in a factored formatting. But as soon as you start multiplying stuff out, you start losing information. Just hold on to that until later in the year when we start talking about factored form more thoroughly.